Welcome back to Cosmos in a Pod Space and Astronomy series, episode 14. Today, we're going deep, deep into the Milky Way Galaxy, our cosmic home.
That's right.
We'll be journeying through billions of years, from the Milky Way's formation to its ultimate fate, uncovering fascinating facts and some mind-blowing concepts along the way. So
It'll be a wild ride.
buckle up.
Yeah.
Okay, let's rewind all the way back to the Big Bang, roughly 13.8 billion years ago.
Yeah.
Where does the story of the Milky Way even begin?
So it all starts with these tiny fluctuations, little tiny fluctuations in the density of dark matter and gas, just moments after the Big Bang.
Right.
Think of them like little seeds scattered across the vastness of space. Gravity gradually pulled these seeds together, causing them to grow and merge, eventually forming the first galaxies, including our own Milky Way.
So from these tiny irregularities, something as immense as the Milky Way emerged. It's hard to wrap my head around that. These early building blocks, what were they like?
Yeah, so these were protogalaxies, swirling clouds of mostly hydrogen and helium, the leftover ingredients from the Big Bang.
Okay.
Imagine this cosmic dance, with these protogalaxies constantly colliding and merging, creating larger and more complex structures.
So the early universe was a pretty wild and chaotic place, with these proto-galaxies just bumping and grinding into each other.
Yeah.
I'd imagine things were pretty hot and explosive back then.
Absolutely, you're right. Within these protogalaxies, the very first stars ignited. These were the population 1,000 stars, massive giants composed purely of hydrogen and helium. These stars lived fast and died young, ending their lives in spectacular supernova explosions.
Supernovae. I remember learning about those in school. They're like cosmic fireworks, right?
But they're more than just pretty lights, aren't they? Precisely. Supernovae are essential for creating the elements that make up, well, everything we know, including ourselves. When these massive stars explode, they forge heavier elements like carbon, oxygen, and iron, and scatter them across space. These elements become the building blocks for future generations of stars and planets, and ultimately, life itself.
Wow, so we literally owe our existence to those ancient exploding stars. That's incredible. Okay, so we had these mergers creating a larger galaxy, but how did the Milky Way get its iconic spiral shape?
That's a great question. About 10 billion years ago, gravity and the spinning motion of all that gas and dust, it caused the Milky Way to flatten out into a rotating disk.
Okay.
Think of it like spinning pizza dough. It spreads out and becomes thinner as it spins. This disk is where the action is. It's full of gas and dust, the perfect ingredients for forming new stars, including our own sun.
So the disk is like the bustling heart of the Milky Way, a cosmic nursery for stars. What about those mesmerizing spiral arms? They're so prominent in images of spiral galaxies. What even creates them?
Yeah, those spiral arms, they aren't fixed structures, but rather waves of density that move through the galaxy's disk. Think of it like a traffic jam in space.
Okay.
As these waves pass through, they compress gas and dust, triggering bursts of star formation. This is why spiral arms appear so bright. They're filled with young, hot stars.
So it's not just a beautiful design, it's a dynamic process that's constantly shaping the galaxy.
That's fascinating. Now, we can't forget about the central bulge, that bright, dense region at the heart of the Milky Way. What's happening in there?
The central bulge is like a time capsule, home to some of the Milky Way's oldest stars. Formed early in the galaxy's history, it's a dense and crowded region, and at its very heart lies a monster,
Oh,
a supermassive black hole called Sagittarius A.
a black hole. Now, that's what I call a plot twist. Tell me more.
Sagittarius A is a gravitational giant with a mass equivalent to about 4 million suns. While we can't see it directly, its immense gravity affects the motion of stars and gas all around it. So this invisible monster is essentially controlling the galactic center, pulling the strings of the entire region.
You got it. Its influence is profound. It plays a key role in the evolution of the galaxy as a whole.
So we've got this bustling disk where stars are forming, the majestic spiral arms, and this enigmatic central bulge with its supermassive black hole lurking within. But the Milky Way doesn't stop there, does it? There's more to explore beyond the disk, right?
You are absolutely right. Surrounding the disk and the bulge is a vast spherical region called the galactic halo. It's like a giant invisible bubble encompassing the entire Milky Way.
What's out there in this halo? Is it just empty space?
No, not at all. The halo is home to ancient stars, some of the oldest in the Milky Way, as well as globular clusters, tightly packed groups of thousands or even millions of stars.
Wow.
These objects provide valuable clues about the galaxy's early history, acting like cosmic fossils, preserving remnants of the Milky Way's past.
So the halo is like a treasure trove of ancient relics, offering glimpses into the Milky Way's long and eventful history. Now, I've heard about this concept of galactic cannibalism. Is that something that the Milky Way has engaged in?
Indeed. The Milky Way, it didn't reach its current size by simply existing peacefully. It has a history of merging with and absorbing smaller galaxies over billions of years.
So the Milky Way has been on a cosmic shopping spree, gobbling up its smaller neighbors.
You could say that. And we can actually see evidence of this galactic cannibalism in the form of stellar streams. These are long, ribbon-like trails of stars left behind as dwarf galaxies are torn apart by the Milky Way's gravity.
It's like the Milky Way leaves a trail of cosmic crumbs behind after its galactic feast. What about our galactic neighbors, the Magellanic Clouds? Are they also destined to be consumed by the Milky Way?
That's a very real possibility. The Magellanic Clouds, they're currently orbiting the Milky Way, but their fate is uncertain. It's a cosmic dance with these gravitational forces at play, potentially leading to their eventual merger with our galaxy.
So the Milky Way might continue to grow and evolve, adding to its already impressive collection of stars and gas. Okay, so let's recap. We have this magnificent barred spiral galaxy with its distinctive spiral arms, the center bulge housing a supermassive black hole, and this vast halo surrounding it all. But where do we fit into this grand cosmic picture? Where's our little solar system located within this vast structure?
Our solar system resides in the Orion Arm, a relatively minor spiral arm located about 26,000 light-years from the galactic center. It's a relatively quiet and calm region, which has been beneficial for the development of life on Earth.
So we're tucked away in a peaceful corner of the Milky Way, far from the chaos of the galactic center. That's good to know. Now, to put things into perspective, how big is the Milky Way exactly?
The Milky Way is a true behemoth. It spans about 100,000 light-years in diameter. To put that into perspective, if you could travel at the speed of light, it would still take you 100,000 years to cross our galaxy. It contains hundreds of billions of stars. Some estimates put it as high as 400 billion, along with countless planets, moons, asteroids, and vast clouds of gas and dust.
Those numbers are mind-boggling. It makes you realize just how small and insignificant we are in the grand scheme of things. So we're just one tiny planet orbiting one star among hundreds of billions in this vast galaxy. And the Milky Way itself is just one of countless galaxies in the observable universe.
That's right. It's a humbling realization. It puts our everyday worries into perspective.
Now let's talk about the Milky Way's ultimate fate. What does the future hold for our galaxy?
In about 4.5 billion years, the Milky Way is on a collision course with our nearest major galactic neighbor, the Andromeda Galaxy.
A galactic collision. That sounds like something out of a science fiction movie.
It's certainly a dramatic event, but it's not as catastrophic as you might imagine. The distances between stars are so vast that individual stars colliding is unlikely. Instead, it'll be more of a galactic merger. The gravitational forces will reshape both galaxies, eventually creating a new, larger elliptical galaxy, often nicknamed Milkomeda.
Milkomeda, I love it. It's like a cosmic mashup, the ultimate blend of two galaxies. So the Milky Way, as we know it, will cease to exist, but it'll be reborn as part of this new giant galaxy. It's a reminder that the universe is constantly evolving and changing.
Exactly. And this collision is just one chapter in the Milky Way's long and eventful story.
Well, this deep dive has already been incredibly insightful. We've journeyed through the Milky Way's formation, explored its structure, and even glimpsed its ultimate fate. But I know there's still so much more to uncover. Are there any lingering mysteries about the Milky Way that scientists are still trying to solve?
Absolutely. Despite all we've learned, there are still many unanswered questions about our galaxy. For example, we're still trying to understand how Sagittarius A, that supermassive black hole at the center, actually formed. Another big mystery is the nature of dark matter. This mysterious substance seems to make up a significant portion of the Milky Way's mass, but we still don't know what it is.
So even with all our technological advancements, the Milky Way still holds many secrets. It seems like there's always more to learn and explore.
That's the beauty of science. It's a continuous journey of discovery, and the Milky Way is a vast and complex laboratory full of wonders waiting to be revealed.
Well, this has been an absolutely mind-blowing start to our deep dive into the Milky Way. We've covered so much ground, from the galaxy's formation to its eventual merger with Andromeda. Join us for part 2 of our Milky Way exploration, where we'll delve into the mysteries of dark matter, uncover the secrets of exoplanets, and explore the ongoing research that's pushing the boundaries of our understanding of our cosmic home. Until then, keep looking up and never stop questioning the universe.
I'll see you there.
All right.
Bye.
Bye. Welcome back to our cosmic journey through the Milky Way. Last time, we talked about the Milky Way's impressive size, its dramatic history of galactic cannibalism, and its future collision with Andromeda. This time, we'll delve into some of the more mysterious aspects of our galaxy, starting with dark matter. You mentioned earlier that dark matter makes up a significant portion of the Milky Way's mass, but we can't see it or directly detect it. It sounds like something straight out of a science fiction novel.
It is. It's one of the biggest mysteries in astrophysics. It's fascinating and a little bit spooky to think about all that unseen matter just out there.
So how do we even know it's there if we can't see it?
Well, we can infer its presence through its gravitational effects. So imagine you're watching a merry-go-round spinning.
Okay.
You notice that the horses on the outer edge are moving much faster than you'd expect, based on the visible structure of the merry-go-round. That would suggest there's some unseen mass, some hidden force providing the extra gravity to keep those horses from flying off.
That's a great analogy. So we see stars and gas moving faster than they should in galaxies, including the Milky Way.
Yeah.
Indicating there's something massive out there that we can't see. What could this mysterious dark matter be?
That's the million-dollar question. Scientists have proposed many theories. Some believe it's made up of exotic particles, unlike anything we've ever detected before. Others propose it could be tiny black holes, or other objects that don't emit light. The search is ongoing, with experiments and observations around the world and in space, trying to unravel the secrets of dark matter.
It's incredible to think that something so fundamental to the universe remains such a mystery. Speaking of mysteries, let's shift gears a bit and talk about another fascinating topic: exoplanets. These are planets that orbit stars outside our solar system, and it seems like we're discovering new ones all the time. How do we find these exoplanets, considering they're so far away and often overshadowed by the brilliance of their host stars?
It's a remarkable feat of scientific ingenuity. There are a couple of clever methods. One is called the transit method. So imagine you're watching a distant star, and a planet passes in front of it, blocking a tiny bit of its light. We can detect this dip in brightness and use it to infer the presence of a planet.
So it's like a miniature eclipse, but on a cosmic scale. That's amazing.
Precisely. Another method is called the radial velocity method. As a planet orbits a star, its gravity tugs on the star, causing it to wobble slightly. We can detect this wobble by carefully measuring the star's light spectrum, revealing the presence of an unseen companion.
So by carefully observing the light from distant stars, we can indirectly detect the presence of planets orbiting them. It's like deciphering a secret code hidden within starlight.
Exactly. And these techniques have revealed a truly astonishing diversity of exoplanets. We've found gas giants larger than Jupiter, rocky planets like Earth, and everything in between. We've even found planets orbiting two stars, like something out of Star Wars.
Wow, that's incredible. It makes you wonder what other strange and wonderful worlds are out there waiting to be discovered. Now back to the Milky Way. How many exoplanets do we think are out there in our own galaxy?
Based on our current understanding, it's estimated that there could be more planets than stars in the Milky Way.
So potentially hundreds of billions of planets in our galaxy alone. That's mind-boggling. Do we think any of these planets could be habitable, like Earth?
That's a question that drives a lot of current research. The search for habitable exoplanets is one of the most exciting areas of astronomy. We're looking for planets in the habitable zone of their stars, the region where conditions might be just right for liquid water to exist on the surface, which is considered a key ingredient for life as we know it.
It's thrilling to think that there could be other worlds out there with oceans, continents, and maybe even some form of life. It makes you feel a little less alone in the vastness of space.
It certainly does. The possibility of finding life beyond Earth is one of the most profound questions humanity has ever asked.
This deep dive into the Milky Way has been incredible. It's humbling to learn about the sheer scale and complexity of our galaxy, and to realize how much we still don't know. But as you said earlier, that's the beauty of science. It's a journey of discovery, and the Milky Way provides an endless frontier for exploration. Join us for the final part of our Milky Way deep dive, where we'll discuss some of the ongoing research and future missions that are poised to revolutionize our understanding of our cosmic home. Until then, keep looking up and never stop questioning the universe. Welcome back to the final part of our deep dive into the Milky Way. We've explored the galaxy's dramatic history, uncovered the mysteries of dark matter and exoplanets, and contemplated the Milky Way's eventual merger with Andromeda. Now let's turn our attention to the present and future. What are some of the ongoing research efforts and missions that are expanding our understanding of this incredible galaxy we call home?
Well, there are so many exciting projects underway. One that stands out is the Gaia mission, a space observatory launched by the European Space Agency. It's creating a 3D map of the Milky Way by measuring the positions, distances, and motions of over 1 billion stars.
1 billion stars. That's an astronomical amount of data. How does Gaia even begin to collect all that information?
Gaia is equipped with incredibly precise instruments that allow it to pinpoint the locations and movements of stars with remarkable accuracy. It's like having, a cosmic GPS, mapping out the stars with incredible detail.
That's an incredible feat of engineering. What kind of insights are we gaining from all this data?
Gaia's data is revolutionizing our understanding of the Milky Way's structure, evolution, and history. We're learning about stellar streams, those remnants of ancient galactic mergers, and gaining a clearer picture of how dark matter is distributed throughout the galaxy.
So it's like piecing together a giant cosmic puzzle, revealing the intricate workings of the Milky Way. You mentioned earlier that scientists are still trying to understand the nature of dark matter. Are there any missions specifically focused on solving that mystery?
There are many experiments around the world and in space dedicated to detecting and characterizing dark matter particles. These experiments use a variety of techniques to try to, capture these elusive particles, hoping to shed light on their properties and origins.
It's like a cosmic detective story, with scientists searching for clues to unlock the secrets of this invisible substance that permeates the universe. Now, I can't let you go without asking about the James Webb Space Telescope. It's been making headlines with its stunning images of distant galaxies. What role is it playing in our understanding of the Milky Way?
The James Webb Space Telescope is a game changer for astronomy. It's powerful. Its powerful infrared capabilities allow it to see through dust clouds, revealing hidden regions of star formation within the Milky Way. It's also providing us with unprecedented views of the galactic center, giving us a closer look at the supermassive black hole lurking there.
Wow, it's amazing to think that we can now observe these cosmic phenomena with such clarity. With all these incredible missions and research efforts, it seems like we're entering a golden age of astronomy.
Absolutely. We're living in an exciting time for anyone who's ever looked up at the night sky and wondered about our place in the cosmos. With each new discovery, we're gaining a deeper understanding of the Milky Way, our cosmic home.
This deep dive has been an incredible journey. It's reminded me of the vastness and beauty of the universe and the importance of continuing to explore and ask questions. Thank you for joining us on this cosmic adventure. We hope you've enjoyed exploring the Milky Way with us. And remember, the universe is full of wonders waiting to be discovered. So keep looking up, stay curious, and don't forget to follow and subscribe to Cosmos in a Pod for more explorations of the universe.